All right. Yeah, welcome everybody. Let's talk about web workers. Sorry about the delay. I was definitely still driving home when I was supposed to start the stream, but here we are, so let's kick it off. What you see on the screen right now is a nice little Mario animation where he's just running back and forth, left and right. That's going on because I'm pressing the left and right arrows. It's just a real simple little script, but this Mario animation is done entirely with CSS. There is no JavaScript involved. But here's what I want to do. I want to set Mario to run indefinitely. I cannot remember if I have set a class here that will make that work. Oh, well, that's weird. That's not what I expected. Anyways, so we're just going to get him running left and right, and I'm going to keep him going. Now, the purpose of this demo is to show off, like I mentioned, web workers. Web workers, if you're not familiar with them yet, they are essentially a way to do multi-threading in the browser. So you can run processes in JavaScript aside from your main UI thread. So anything that's going on in the UI thread doesn't get affected by, say, large calculations like calculating a number of prime numbers, right? So what we're going to do here is I'm going to go ahead and say, I think 30,000 is a pretty good number, but essentially what's happening here, you see, as I move my cursor left and right in my text input, it definitely still moves Mario. Not very encapsulated stuff that I've got going on here. Anyways, oh, auto run, there we go. So now he'll just run forever. I knew I'd done something like that. Anyways, so 30,000, what's gonna happen is when I hit one of these buttons, the JavaScript is gonna start trying to get all of the prime numbers between 0 or between 1 and whatever number we put in this input. So right now 30,000. So if I say get primes with no worker, we should see Mario sort of lock up for a second. Oh, no, doesn't look like he had any issues there. I may not have gone high enough. So we're gonna do this, okay. Great, Mario's still doing what he's supposed to. Okay, so that one right there took 10 milliseconds, which is pretty insignificant. So let's go up to 300,000. Between 1 and 300,000, we're gonna find prime worker or prime numbers. Okay, so you saw a little bit of a blip there. You can see he kind of, well, maybe you might be able to see that on the stream, you might not. Let's go up to 500,000. Let's do 500,000 and see if we get something a little more significant. Okay, not really. Okay, let's go up to 1 million. Mario's doing a moonwalk for us here. And let's see, there we go. What? How does that happen in half a second? Okay, we'll do 2 million. Every time we increase this number, it should be an exponential increase in the amount of time that it takes for the computer to calculate it. So let's go to 2 million. There we go. Now, geez, seriously, still less than a second. All right, we're gonna jump up to 5 million and see what happens. There we go. 2 seconds. This doesn't seem right. I'm pretty sure I remember the last time I ran this demo, I was able to do 5 million and actually like crash the browser. So we're gonna jump up to 10 million and see what happens. There we go. Now we've got a little bit more of a blip. You can see Mario's just sort of chilling. All right, so a little short of 6 seconds. Let's do like 20 million. And that should give us a nice long time. I'd figured out how high I needed to go to get like right at a 30-second blip. Last time I used this demo, I actually did it for a talk at Mad.js. But anyways, so yeah, 11 seconds is what that took us, and Mario was just frozen there in the middle of the screen. We'll do it one more time. Okay, we'll see. It'll be around 11, 12 seconds again. and then Mario will start running again. And the reason for this, again, is because we're using get primes, no worker. So we're not offloading this calculation. We're just running it in the main UI thread. So let's try doing it with a worker. We'll run it. Okay, well, it started, and Mario's still going with no issues, which is cool because there we go. It returned, and not only did it return, but it was actually twice as fast, which was also surprising last time I used this demo because web workers are supposed to be like way slower than doing stuff in the UI thread. Anyways, we'll up this to 50 million now and see. Oh yeah, that's not what I meant to do. Well, we'll probably get like 30 seconds about out of 50 million, calculating all the primes between 1 and 50 million. So I'll just talk for a second. The stuff that's going on behind the scenes here, I'm going to get into here in just a couple of minutes. But the point is that web workers not only are surprisingly faster than, there we go, yeah, right at 30 seconds. Cool. So that's like 10 times more than I did last time. Anyways, yeah, so it took about 30 seconds in the UI thread, and if we run it here, it'll take forever, but we'll see Mario keeps on running, and that's because, again, we're offloading it to a web worker, which means that this operation is happening on a separate thread on your processor. So when we do it without a worker, it runs in the same thread as what's generating Mario running back and forth, and then when we're doing it with a worker, it's running on a separate thread. So we've got the UI thread, and we've got whatever our worker threads are. And we can have, I have no idea how many, it depends on the processor. At some point you will crash things, but it's still fun to experiment. And yeah, we can look, so with or without a worker, 30 seconds, with a worker, 16. So it's twice as fast, and that blows my mind because it's really not supposed to be. It may be because we're doing other things in the UI thread, and this is running in the UI thread. I hadn't thought about that part, but anyway, so let's look at the code. What I'm going to need to do is, let's see, I'm actually going to open folder. We're going to create a new one here. Let's Pair is a project that I'm working on that you guys might be interested in soon, but not yet. We'll say worker demo. Great, we'll open that, and then I'm just going to wget those files. Doop-a-doop-a-doo. We're going to go to development, worker demo, and we're going to wget trezzy.sh/worker demo.html, and then we'll get worker demo.css, and we'll get worker demo.js, and that should be everything that we need. Okay, so we've got HTML, it pulls in the CSS, and the JS. Great, so that works. All right. Now, the HTML you can see is super simple. I haven't even got the body tag or the HTML tag. If you didn't know, those are completely optional, by the way. The browser will usually do a pretty good job of injecting those for you if you want. So just a little pro tip there. However, we're doing some simple stuff. So we import a CSS file, a style sheet. We set up our two buttons. One for getting primes without a worker, one for getting primes with a worker. We've got our little auto run toggle, which is just what we used to make Mario either stand still or run across the screen by himself. And then our input for setting our number of primes. Oh, I actually maxed it at 50 million, so maybe that's not more than I thought. Anyways, okay, so we've got our Mario div. And then we're importing our worker demo. So let's look at the CSS real quick, because the CSS is also pretty simple. This is mostly just boilerplate stuff. Our Mario, we have an animation set up on him. So it's a CSS animation, like I said, not JavaScript at all. We set the background image, which is actually a sprite. If I hover over this, it should show. We're actually gonna, I'll pull that up in the browser so you can see what the sprite looks like. Yeah, so that's the sprite. It's just a whole bunch of little Marios doing little things. We're only using the running and the standing part of it. But yeah, so that's our sprite. And our animation is just stepping through that sprite for half a second and setting some styles just to give him a size and such. We use that nifty little zoom too, if you've never seen that. If you have, then it's probably because you have had to support IE7, but if not, yeah, zoom is a nifty little feature that you probably shouldn't use because it usually breaks things and it's super render intensive. Yeah, if we hit the left arrow key, then we just add this left class, which causes him to flip. If we hit the right arrow key, we remove the left class, so it's not flipped anymore. When he's running, we switch the animation name, and that's about it. We add the running class, which switches the animation name, and then auto run does basically the same thing. Yeah, and these are our animations. So standing, we just change the background position, which is how the step works, or the steps thing. So we say, if you've never used a steps timing function animation in CSS, they're pretty cool and really useful if you have an animation sprite. So we're saying 8 steps for running, and in our running animation and our keyframes rule, we've got our background position set at -240 and then -560. So basically what's going to happen is the browser is going to interpret, okay, what's the difference between this 240 and this 560, which is like 320 pixels, 320 pixels, and it's going to divide that by 8, which I'm not doing in my head. So 320 divided by 8, so it's 40 pixels each. So we'll just move the image background position, essentially 40 pixels every step, and then we spread those steps across our duration, which here is half a second. So yeah, I should probably go into those a little more one day because they're pretty darn cool, like I mentioned. So that's our CSS. Let's look at our JavaScript. Now we've got our Mario class is basically all there is to it, I think. Yeah. Mario class has a bunch of stuff just for animating Mario, right? So we're just in our constructor, we set our basic speed with a default of 5, so we can change that whenever we construct a Mario class. We use my bind events thing and then animate. So the bind events right here watches the auto run toggle, which is that little checkbox, and it listens for key down and key up. On key down and key up, it'll check what those keys are. If it's left or right, it'll do something. If not, then it will ignore it. Yeah, and then yeah, move left and move right just set styles, so they add a class. That's pretty much it, and then adjust the left based on where we're currently at. Let's see, bind events. Animate just checks values on the class and adjusts what Mario is doing based on it. And I think that's most of it. Yeah. Then we've got our get primes function, and our get primes with worker function, which has some stuff that you may not have ever seen if this is new to you. So we're creating Mario with a speed of 4, and then these are just setting up the click events on the buttons so that we'll run these functions when we need to. Now, get primes is a simple function just to get primes, right? It just, we get our performance.now. Performance API is high resolution timing API in the browser, which is relatively new within the last couple of years. And then this is just our formula right here for calculating primes between 0 and 1. Right, and then we're just logging out the results of this stuff. Get primes with worker, however, does it a bit differently. So again, we do performance.now, but then we create a new worker, which in the browser is the syntax for creating a new worker, or a new web worker. And what we do is we pass it a file, so a file path. In this case, worker.js. So we need to wget that. So we'll do worker.js. And what this is going to do is spin up a new thread where all it does is loads that file, which has a little bit different syntax than most things. If you have used the post message API before, then some of this may look familiar, but we're going to use self as a context instead of this inside of our worker. What we're going to do is set an event listener on it for a message. And then anytime that message event fires, we'll do some stuff. Right here, all we're doing is, once again, we're calculating those prime numbers, right? And then once we're done, we will use the post message API to respond. We're going to say, basically self.post message. So we're posting a message to ourselves within the worker, which is a stringified copy of the primes array. Now, if we go back to our JavaScript, in our primes, get primes with worker function, you can see, so we create the worker, and then we say worker.add event listener message. Okay, so basically on this side, on the main UI thread, when we listen for a message event on a worker, it's going to be anytime a worker calls post message on itself. So we could do post message to the worker all we want. It will not fire this on the UI thread. But from the worker thread, when we post a message, we'll only hear it on the UI thread. So yeah, we've got our add event listener for message, and then once we get a message, we'll check event.data. So back in the worker.js, we do post a message, and then we pass in this stringified copy of the primes. That's because we can't pass an actual JavaScript object because it's transitioning between threads. It'll lose all of its context. So we turn it into a string and ship it back to the UI thread, and it becomes the event or the data property of the event that's passed back. So we're going to parse that back into an object, which is going to be an array. And then we're going to terminate the worker. So this is going to close that thread. If you don't do this, you'll probably end up with a bunch of threads, a bunch of derelict threads just hanging out in your application, which is real bad. You shouldn't do that. But the other important thing to note here is that you don't necessarily have to terminate the worker as soon as it's done doing its first thing. You can use workers to do all kinds of stuff. I have another demo that I might bring up before the end of the stream, where I'm using workers to download images rather than using the regular old image tag in the browser. So instead of terminating the worker thread, I pass things to it, and then I don't terminate it until it's completely done downloading the images, and then I terminate threads. So we can call worker.terminate to shut down that thread, and then we log out our results, which is pretty simple. And then after we've set our event listener, because we don't want our event to fire before we set up a listener, so after we've set up our listener, we will post a message, which is going to be json.stringify max. So we're just going to take max, which is our value from the input box. So this value is what gets pulled in as max. And we're going to pass that through. We json.stringify that, which just turns it into a regular string instead of an integer. And then we're going to post it to the worker. And then the worker receives that event and goes through all the functionality. So this is a really simple worker. You can do all kinds of crazy crap in workers. So let's actually pull up. Let's see if I have the image worker demo on here. I don't know if I do. It doesn't look like it, so we will pull that down real quick. Trezzy. And my repositories, my beautiful face with that big old bushy beard. Let's see, worker. Yeah, web worker image preloading test. Cool, so let's clone that. Oh, I actually just cloned that into the worker demo. Well, that was silly. It's going to take a minute because there's a bunch of big images. I wanted the images to be sizable so that we could really see how well it works. But we'll give this a second. Okay, what are we doing with package.json? Anything special? Nope. Okay. So the server. Okay. So I'm gonna go down a level and CP worker demo image worker, yeah, to right here. So that'll, oh no, that's not what I want to do. I want to move it. Yeah. Okay, there we go. So now we should have everything we need. We're gonna yarn install or npm install, whichever you use. Okay, and then I'm gonna do node server, and that should start our server. No? Oh, I just tried to install node modules in my development folder, which is super awesome. I do this all the time. I really need to stop or like write a thing to make it not happen anymore. All right, go into our image. There we go. Now we're gonna yarn install. Okay, now, there's not much to it because it's just a server. So now if we run node server.js, oh, I've probably got, yep. Got another server running on 3000 right now, so let's try that again. And there we go, we should be working. So if I go to localhost 3000, yay! All right, so there's a lot of stuff going on here. You'll see the images pop in kind of slowly, because again, they're all pretty big images. Yeah, and so there's a couple more still coming. This progress bar down here at the bottom, this blue bar, if you noticed while things were loading, that's actually showing the loading progress of the images. So let's just read this out real quick. This experiment will spin up a new web worker for each image on the page. Inside of the web worker, the image will be downloaded as a blob via XML HTTP request. If you're not familiar with blobs, they're I'm not sure what the best explanation for them is, but I think they're basically binary representations of chunks of data. So you can have multiple blobs to represent, or no, it's multiple chunks to represent a single blob, which can be like an image, or you can even use a blob to have worker directly in your code rather than having to load a separate file, things like that. So inside the worker, we're going to use XML HTTP request to download the image as a blob. Then we read the data via the as a data URI via the file reader API. Finally, pass it back to the UI thread to be injected as the source of the original image element. Now this is kind of crazy. So let's take a look at the code real quick. Yeah, so we've got it now. Okay, so index, here we go. This is where the magic starts. We just import our app.css or app.js file. And then down here, we have, 49 through 25, so 24 images. And they're all pretty sizable. So if I hover over this guy, no, that won't tell me. Let's just look at it in here. Say, split that, go to development, image, no. There we go. And then we'll go to assets. NLSLHAG. Oh. Go to images and then try it again. Okay, here we go. So yeah, I mean 8.7 megs, 10 megs, 11 megs. What's ours? 17 megs. I think that 17 megs is our biggest one. So that is whatever this 168.765 images. So yeah, they're all pretty sizable. Only a couple of them are under a meg. Most of them are well over a meg. So they should take not too long, but a little while to load. Now, what we're doing in our HTML is instead of using an image with a source attribute, we're using data-source. If you've never used data attributes before, the idea is that I can basically prefix anything I want with data hyphen, and then it's considered a valid attribute in HTML. So I can say data hyphen Trezzy is the best equals true, because we all know it. I'm just saying it. Yeah, so data attributes are nice and simple. We've got our data source attribute, which is going to be the path to our image, right? And since it's data source, the image tag will not automatically download it because it doesn't know what data source really is. If it was just source, then it would automatically load the images. Now, what we're doing here in our JavaScript file, assets app.js. All right, so what we're doing in our JavaScript file is we get all of the images on the page, and then we create an object which we'll use to store the progress for all of these images, which is kind of a weird thing, but it works. Grab our progress bar so we can keep that updated. And then we're going to get location.href, which is what we're going to use to create the URLs for the images that we're going to grab. So, you know, assets/images/leaser.jpg. We're going to append or prepend whatever location.href is. So in this case, localhost 3000. And then up here, we check to see if there is a base URI, because if we're on localhost 3000, we won't actually get anything back. It'll just be an empty string. So we'll just add a slash to say whatever the root of the current project is, that's where we're going to get stuff from. Our update progress method is pretty insignificant at this point. But down here, and you'll see this code is pretty well commented. So I'll post a link to this repo in the comments or in the description when I finish the stream. But for now, we're just going to go through the code. Okay, so we just loop over all of the images. Again, we're going to grab performance.now so that we can sort of track our speed in setting everything up. Then we memoize current image, which is just saying instead of accessing it from the array every time, we're just going to store it in a variable here. We grab the data source, and then we create a new worker, which loads this image loader.js, which we'll pull up in a second. Create our progress details, and then we post a message to our new worker with the base URI plus the image source. So that's just going to say whatever your path is what gets posted to the worker, and the worker will start acting on that. So next up, we'll set an event listener for messages, so when the worker is done downloading the image, we'll get our message back. Before we get into this, because this is all really not that important, so we'll switch over to looking at the image loader worker. Now this is a lot more complicated than our previous image loader because because we're doing a lot more complicated things, but also because I'm setting up all of my methods beforehand, and then down at the bottom here, I set my event listeners. So we've got listeners on the reader, which is our file reader. We've got listeners on the XHR, which is our XML HTTP request, how we're loading the image. And then we've got a listener on self, which again is the worker, for message. And then we'll run the handle message function on that. So let's take a look at our handle message function, which is up here. So handle message, we get the event. Event.data is the URL that we passed in for the image, so the image path. Now we're doing a switch statement to say if the data is just the string of close, then we'll actually do self.close, which causes the worker to terminate itself. So in our UI thread in the Mario demo, you saw that we were calling worker.terminate from the UI thread. In this case, we're actually giving the worker an opportunity to close itself. And from inside it, we use self.close instead of self.terminate. I don't know why they're different, but they are. But we'll do cleanup first, which basically just removes all of our event listeners. If it's not that, then we'll go down and handle the image data. So data being our event.data. So handle image gets the URL for the path for the image. So handle image is right up here. And we will basically set up our XHR, which we actually create up here so that it's easily available to all of the functions. It's just in the global scope for the worker. And then down here, we set up the information. So we say a response type blob. So we're gonna, whatever response we get back, we're going to convert it to a blob. And then that allows us to read it with the file reader. Then we open it, which is gonna get it ready to be shot off. So we've got a XML HTTP request ready to send, and then we send it. So again, that's all really simple stuff. And this, at this point, it looks like it's kind of a black box. So down here in the XHR, we actually have a couple of functions to check for progress and load events. So progress is going to be anytime we get information, anytime we get another chunk of data back from the XHR, because the image doesn't load all at once, it's going to load incrementally. We'll do some stuff, handle XHR progress, basically just responds back to the UI thread and says, hey, we've made this much progress. And what we're doing to do that is we're actually creating an object and passing a type and a value, and then stringifying that object immediately and posting it back to the UI thread. Now on load, that's the one that we actually care about right here. So handle XHR load is immediately going to call the file reader and have it read as a data URL whatever we've gotten back from the XHR, which is going to be the response. So let's look at the reader. I'm sorry. So yeah, basically what this does is the file reader API, this guy right here, where we've created a new reader, this guy will read the response data from our XHR and then convert it to a data URI. So if you're not familiar with data URIs, it's just a string representation of binary data. So our image, which ultimately is binary data, is converted to a data URI, which we can put directly into the source attribute of an image tag, and that'll cause the image to load. So again, down here we say reader.read as data URL, and then we have more event listeners on the reader because I really like event-based architectures. So we've got load and progress, which is the same thing as the XHR. Load is when it's done. Progress just says we've read this much of the file. So in load, handle file load, that's where things sort of wrap up. There we go. I guess I could just do this, but anyways, here's our function, handle file load. We're gonna post a message back. Again, it's a object with a type and a value that we stringify and then post back to the UI thread with post message. Now, I just realized that I don't have the chat open. Let me pop that up real quick. I'm sorry, guys. If anybody has been chatting to me there. Yep, there's definitely been chat and I have not been looking, sorry. Okay. So this ought to help a little. Okay, cool. Suddenly Trezzy stream, code to efficient, rest in peace. Thank you. Yes, Absolver, there are Snickers. And Alex says close is private, terminate is public. You should use close internally and terminate when interacting with the worker from the outside. Gotcha. Okay, thank you for clarifying that. So what he's referring to with that message is that inside of the worker, we do self.close, which is a private method on the worker, whereas outside of the worker in the UI thread, self.terminate or worker.terminate will close the worker and shut down the thread. So yeah, thanks, Alex. Let's see. Okay. Now, back to handling our file load. Doop-a-doop. Yeah, so we say a type and a value. Type is basically how I am on the UI thread determining how to respond to this message. In this case, we're saying result, and we're passing reader.result, which is going to be the data URI of the image. Now, if we go back to app.js, finally, cool, here we are. We're listening for a message, and then we act on that message. We've got an event. We're going to json.parse the data and grab the value. And then based on what the data type is, we'll do different things. So if it's progress file, then we'll update our progress so that it correctly displays, we're this far in files. And then there's another one for loading the actual image from whatever path we've called it on. And then our result, which is where we will take the image, which we've stored up here. So image, if you recall, up at the very top, we did document.querySelector all, so we get all of the image elements. So we've got the image nodes here, and then we're looping through them. So we've got an image node is what this refers to. So down here, we're going to say image.source, and we'll set that to the value, which again is going to be a data URI. And then we tell the worker to close itself. We're telling it from the outside. We could just do worker.terminate, but I'll go back and show you why we're not here in just a minute. And then we just log out some stuff saying how long this image took to load. So why do I post message close instead of doing terminate? That is because inside the image loader worker, we watch for that event. Here we go. And we run this cleanup method, and then we say self.close. The cleanup method, is this guy right here. And basically, it goes back over all of our elements and removes the event listeners. So this may or may not be necessary because it's inside of a worker, and when you close the thread, all of that stuff should be killed implicitly. But I decided to be explicit with this one. We actually delete the reader, we delete the XHR, and this guarantees that there's no derelict things existing in memory. So it saves us a little bit of memory, hopefully. All right, now we're back to app.js. Yeah, and that's the gist of it. So let's go back and look at it work again. So we've got our image worker, loader, we'll reload it, and you'll see each image pops in. Now, I'm not opening the console until they're completely done. And the reason for that is because, almost done. One more. There it goes. Okay. Because data URIs are huge and they cause my dev tools to be really, really slow. So you'll see it's taken a little while to load the elements panel, but it'll load eventually. Oh, I even got a beach ball. Yeesh. This is kind of rough. Is it gonna load at all? Well, we've got our consoles anyway. So you can see some of these took, 15 seconds, 14 seconds, 13 seconds, because again, these are large files, so they take up a good chunk of download time. And yeah, we're loading them all. We're sticking them into the image tag, and because we loaded them via an XHR, they're still cached in the browser. So if we actually reload this page and we set the source to just the path, so if we were to say, load everything via a worker, and then as soon as it's done loading, set a flag in local storage saying, hey, we've loaded this image before, then the next time we just set the source, it'll load the cached version of the image, which is pretty sweet. Though pretty tangential to what we're talking about. So we have loaded all these images. That's super cool. What is there to talk about here? If anybody has any questions, feel free to toss out there. It looks like it's mostly rats watching right now. So if you guys feel like, I don't know, making fun of me or asking questions, either way, feel free to drop those into chat. Yeah, so I think that's the gist of it. Web workers are really, really cool. They make it super easy to offload heavy calculations from your UI thread, which is a really good thing. Because right now, if you do all of your work on the UI thread, it takes forever, right? Whereas we can offload those things to a worker and just load the essentials on the UI thread so that the user gets an app immediately. And then because of progressive enhancement, we then get workers loading stuff iteratively, rather than all at once, trying to jam all these images into a page or trying to figure out what all of the primes are between 1 and 50 million as soon as a user hits the page. So you get a little bit better user experience. I can't think of anything else super interesting to talk about on web workers. You got to look at the API. I will post some links, but that's the gist of it. That's web workers. So hopefully you guys have some more information. Make sure to like, comment, subscribe on the channel. Post in the comments as usual. Let me know if there are things that I did that you hated, or things that I didn't do that you would love to see, or topics that you'd like to hear me talk about, anything like that. I think I've decided, I don't know if I'll be able to sustain this rate, but I'm going to try and do 2 streams a week, and we'll see how that turns out. But yeah, all right. Thanks, guys. Have a good one.